These polygons belong in the same group. Show us 3 different shapes. Which statement best describes the polygons in this group? So they want to know, why are they all in the same group? What we have to do is look at our answer choices and see which one talks about something that all of the shapes have. It can't just be one shape or 2 shapes that have this. A says that each polygon has at least 2 obtuse angles. I'm going to use a sticky note. I'm going to start checking the angles of these shapes. I should find 2 obtuse angles or more than 2 obtuse angles for every shape, if this is true. So if I check this first angle, I can see that the corner of my sticky note fits in, but that one of the sides of the angle is kind of sticking out. It leaves this big open space between the line and the sticky note. That means that I have an obtuse angle there. If I check the other angle at the top, I see the same thing. The corner of the sticky note fits into the corner of the angle, but there's a big open space on the side. We have another obtuse angle. If I check the angles on the bottom, I can see that this one, the corner of my sticky note, doesn't really fit in the corner of my angle. The angle is too small. If the angle is too small for my sticky note to fit, that makes it an acute angle. And I can see the same thing on the other side. If I try to put the corner of my sticky note into the corner of the angle, I can see that the angle is too small. I can't see the other line. That's another acute angle. Okay, well, that one did have 2 obtuse angles. Check this next shape. I have another obtuse because my sticky note does fit in the corner, but there's extra room. It's too big. This next angle is too small. Can't see both of my lines, so it's acute. If I check this angle, the sticky note fits, but there's also extra room. This angle is too big. I've got another obtuse angle. And if I check the last angle, I can see that this one is too small. So this shape also had 2 obtuse angles. So far, answer choice A looks pretty good. Now the last shape I can see on this angle here, the sticky note fits perfectly in that corner. It fits just right. This is a right angle. Same thing is true on the other side. The corner of my sticky note fits perfectly into the corner of my angle. So there's another right angle. You can see on this angle that it's too big. My sticky note fits, but there's all this open space. So there's an obtuse angle. And for the very last angle, I can see that it's too small. One of my lines gets covered up. The sticky note won't fit. So that's acute angle. Shape 1 had at least 2 obtuse angles. Shape 2 had at least 2 obtuse angles, but shape 3 only had 1. Since shape 3 only had 1 obtuse angle, I can't pick answer choice A. Answer choice B Each polygon is a parallelogram. Remember when we talked about the different shapes, especially the quadrilaterals? Parallelograms are a quadrilateral. They have to have 4 sides. But to be a parallelogram, it has to have 2 pairs of parallel sides. That's what makes a quadrilateral a parallelogram, having 2 pairs of parallel sides. If it doesn't have those 2 pairs of parallel sides, then it cannot be a parallelogram. The first shape, the top and the bottom, are parallel, because if I stretch those lines out, no matter how far I stretch them, they won't ever touch. So they're parallel. But the left and the right side, if I stretch those out, look what will happen on top of my shape. They would run into each other up here. So those sides are not parallel. So already, just by checking the first shape, I can say that they are not parallelograms. Answer choice C. Each polygon has at least 1 pair of parallel sides. Okay, this is different. This says they have 1 pair of parallel sides. And it says at least 1. So they could have 1 or they could have more than 1. We know that the first shape has 1 pair of parallel sides. So the first one, yes. Let's check the second shape. Yes, Nakai? Right now, Nakai, what are we focused on, sir? Right now, I just want you to focus on the math. I want you to make sure that you're writing this down on your paper. Because again, tomorrow we're going to be taking a test. Tomorrow you're going to be on your own. And if you're not writing these notes down, if you're not following along, I can't help you on the test, and your blank paper won't help you on the test. So I don't want you to focus on anything else except for the math right now. Let's check that second shape. Let's see if it has parallel sides or not. If I stretch out these sides, yep, those are parallel. Those will never ever touch. And if I stretched out the other sides, those ones would never ever touch. So the second shape actually has 2 sets of parallel sides. All up to the last shape. If it has a set of parallel sides, we know our answer. If there's no sets of parallel sides, we have to look for another one. See the top and the bottom. Nope. If I stretch out the top and the bottom, they're going to run into each other over here. If I check the sides, those ones would be parallel. The left and the right side, no matter how long I make those sides, would never ever touch. So every single polygon does have at least 1 pair of parallel sides. D, each polygon has at least 1 pair of perpendicular sides. Well, perpendicular we talked about on the problem right before this. We said perpendicular means that they make right angles. But we checked all of our angles, and there's only one of our shapes that has even one right angle. The first two shapes do not have any right angles, so they do not have one pair of perpendicular sides. So our correct answer is answer choice C. (22) Which figure appears to have more than two lines of symmetry? Symmetry was something we talked about when we talked about the different types of shapes, the different kinds of polygons. Remember, symmetry is, like they say, it's a line you can draw on the shape, and if you were to fold the shape or cut the shape on that line, you would end up with two equal parts. And sometimes in math, they'll use the word congruent. So remember, two equal parts is congruent, the same size and the same shape. I'm even going to write that down here. Same size, same shape. So if I have a line of symmetry, that means that when I draw that line on both sides, not just one side, but on both sides, I'll have the same size, the same shape. I will have two equal parts. So they want a figure that has more than two lines of symmetry, more than two ways that I could fold it and have equal parts. Answer choice F. I could have a line that goes vertically, just like that. And both sides would be equal. Kind of looks like a butterfly when I put the line there. I could go horizontally. And again, the top and the bottom would be congruent. They'd have the same size and the same shape. I could also go diagonally. And I'd have the same size and the same shape. I could even draw the line diagonally the other way. And I'd have the same size and the same shape on both sides. Remember, especially for shapes like this, where it doesn't sit straight up and down, it's kind of crooked, it's leaned over to the side. If you're not sure whether you'd have two equal sides, use your fingers. Put your fingers on either side of the line and start tracing the shape. If your fingers are always doing the same thing, then you know that it's congruent. If you notice that one of your fingers is going down while the other one's going sideways, or if one of your fingers is going sideways and stops, but the other one just keeps going, then you know it's not the same size, it's not the same shape. So answer choice F had 1, 2, 3, 4 lines of symmetry. So that looks pretty good. Answer choice H has a horizontal line of symmetry. My top and my bottom would be the same shape. Got a vertical line of symmetry. The left and the right side would be the same shape. But if I tried to make a diagonal line of symmetry, that wouldn't work. If I try to do it, and again, I use my fingers to start tracing, I can see that my fingers are doing very different things. So I know that these two sides would not match up. So answer choice H only has 2 lines of symmetry. Answer choice G. Answer choice G is one that's here to trick us. It looks like it might have a line of symmetry, but it doesn't. The closest I can get is going horizontally. And it's very, very close. But look what happens when I trace it with my fingers. One side has a point. The other side is flat. So both of these sides would not match. Answer choice G has no lines of symmetry. So far, answer choice F has the most. It has 4. Answer choice H only had 2. Answer choice G didn't have any. Let's check answer choice J. It's got one diagonally here. The left and the right would be the same. See, that line's a little crooked. Let me fix that. That's okay, Brianna. Glad you're back, though. So the left and the right side are equal. I could go diagonally the other way. And the top part and the bottom part would be equal. But if I tried to go horizontally, like this, my two sides would not match up. If I tried to go vertically, my two sides would not match up. So answer choice J has 1, 2 lines of symmetry. The only answer choice that has more than 2 lines of symmetry is answer choice F, because it had 4. $23. Xavier drew a figure in the sand on the beach. It had only 1 pair of parallel sides and 2 obtuse angles. Which figure could be the one that Xavier drew? Okay. So he drew a figure, but they don't show us what it looked like. But they do describe it to us. There was only 1 pair of parallel sides. There were 2 obtuse angles. Yes, Jadine. Okay, well, hang on. Because for these kinds of problems, there's something very specific that I want to make sure that we do. The reason why a lot of people will miss problems like this is because they do something very sneaky here. They tell us about the shape he's drawing. They give us the names of different shapes, but they don't show us what the shapes look like. The reason why they don't show us what the shapes look like is because they hope that some of us forget what these different shapes are. And they hope that we confuse or that we mix up two different shapes. So anytime they're asking you about a shape or about a figure, and they don't show you a picture, I want you to make sure that you draw your own picture. So before I start thinking about which one is correct or which one's not, I'm going to draw all of these different shapes. Because if I can see them, it's a lot harder for them to trick me. I'm going to start with the trapezoid. I'm going to put an answer choice A, so I know this is my trapezoid. Trapezoids can look a couple of different ways, but the simplest trapezoid to draw looks like this. Got a shorter top, a longer bottom, and then the sides are diagonal. Remember, if you have problems drawing a trapezoid, draw yourself a triangle and then just cut off the top part and you'll have a trapezoid. So that's what my trapezoid looks like. B says that maybe what he's drawing is a parallelogram. Okay, so I'm going to draw a parallelogram. Again, one simple way that I found to draw a parallelogram, because I know that they can be tough to draw for some people. I start with the bottom. I just draw a straight line horizontally for the bottom. Then I draw another line horizontally for the top. But the important thing here is that you don't put them on top of each other. They're going to be kind of like that. So they're not lined up straight. One of them should be ahead of the other. Then you just connect them using diagonal lines. So that's my parallelogram. Now, if that's still tough for you, another way that you could do it, still start with the bottom, but then do your sides next. Draw your bottom line and then put your diagonal lines for your sides and then make the top. Whichever way works better for you. Either way, you'll have a parallelogram. Answer choice C says maybe it's a rectangle. Maybe that's what Xavier drew. I'm going to draw a rectangle here. Rectangles aren't too tough. We just need to make sure that when I draw a rectangle, that the top and the bottom are longer than the sides. Or I could make a rectangle standing up. I could make the top and bottom short and the left and the right side longer. So long as I have two long sides and two short sides, that's perfectly fine for a rectangle. And answer choice D says maybe it's a square. For a square, very similar to a rectangle, except instead of having long sides and short sides, everything should be equal. So again, even if they're talking about shapes and you think, oh, I know what these shapes look like, draw them out. Draw them on your paper, because sometimes we get them mixed up with other shapes. If you can see them, it makes it a lot harder for you to pick the wrong answer. Now, Jaden, you said you thought you knew what the answer was. Which one do you think is the correct answer? Okay, why do you think that? Okay. Okay. It does have two obtuse angles, but I want you to read this part carefully. Only one pair of parallel sides. A parallelogram has to have two pairs of parallel sides. See, that's one of the reasons why I like to draw the shapes. Because again, if I think about it in my head and I can't see them, it makes it harder for me. And if I draw them, it doesn't take me very long. It doesn't break my hand. My hand is still okay. And it makes it harder for me to make a mistake. Because if I look carefully at them, I can see, oh, wait. If it says one pair, this has two. That's all right, but that's why we draw them. That's why we do that thing to be a little more careful. Kylie, do you think you see the one that we're looking for? A. Because they said they wanted only one pair of parallel sides, I should absolutely be looking at A. A parallelogram has two pairs of parallel sides. The left and the right, the top and the bottom. A rectangle has two pairs of parallel sides. The left and the right, the top and the bottom. A square has two sets of parallel sides. The left and the right, the top and the bottom. The only one that only has one pair of parallel sides is the trapezoid. It has the top, it has the bottom, and that's it. Because the left and the right are not parallel. If I stretched out my lines, I would see that they would end up running into each other up here. A trapezoid also has two obtuse angles. These ones on the top would be obtuse angles. So you are absolutely right. The shape that we're thinking of or that we're looking for is the trapezoid. That's what he drew in the sand. That's the one that matches the description they gave us.